class, so we are continuing to learn how to multiply fractions by whole numbers, and we are on lesson 24, session 2, and we're on page 507. And this equation or problem starts with this word problem. It says, James is baking cookies. One batch of cookies uses 2/4 of a teaspoon of vanilla. James wants to make 3 batches of cookies. How much vanilla does James need? Now, thinking to the methods that we've used in the past, what method do you think would be easiest for you to use to solve this equation? Would you simply use standard algorithm? Would you just add the fraction 3 times? Would you want to draw an area model? Or how about a number line? I want you to think of the way that you would do it, and I want you to try to do that on your page right now. While you are thinking of the way that you want to do it and working that out, I'm going to work out a couple of the different ways on my page too. So I don't know what you picked to do, but I went ahead and did an addition model. I got my improper fraction. I decomposed my improper fraction. I simply did standard algorithm, where again, we just simply multiply that whole number by the numerator. And I also drew out an area model. I started to accidentally do a 4th column, so I crossed that out right there. Okay, let's flip the page to page 508. Now, what I like about this page is it actually shows you in more pictures how this would look. So we know that James has to use 2/4 of a teaspoon of vanilla for each batch. And so what this first one right here tells you is for the first batch of cookies, we need 1/4 and 1/4, which is 2/4. The second batch also needs the same 1/4 and 1/4, which is another 2/4, and then batch 3 needs again 1/4 and 1/4. And if we were just to simply add all of those up together, we would get 1, 2, 3, 4, 5, 6/4, which would be 6 of these. I would actually pour in 1/4 of a teaspoon 6 times. The other example model shows you area models for your batches, batch 1, 2, and 3, and that's what I kind of drew on the other page, but I didn't put the fractions within. So we see here we need 1, 2, 3, 4, 5, 6/4 to be poured into our batter in order to triple that batch. Okay, so we're going to move on to page 509, and we're simply going to fill out this information with what we knew from the problem. So number 1 asks, how much vanilla does James need for each batch? Well, he needs 2/4, and that's what the equation told us, or the word problem rather. Number 2, how many batches does James want to make? Well, he wants to make 3. So now we're going to write an equation to find out how many teaspoons of vanilla James needs. Well, he needs 3 times the 2/4, and that is going to give us, remember, the 3 times 2, that's going to give us the 6/4 of teaspoons needed. Now, how can we check to make sure that our answer, or how can we check using repeated addition? I kind of already did that for us in our opening. We just simply do those 3 groups of 2/4, and we see that it does indeed equal the 6/4 that it did above. They are the same. It says, write the fraction that shows how many teaspoons of vanilla James needs as a mixed number. I did that as well. We're going to decompose that improper fraction into a mixed number, And for some of us, it's easiest to just pull out the whole, and then we have 2/4 left over, and we know that 1 whole, 4/4 is 1 whole, and 2/4 is what we have left, 1 2/4. So now between which two whole numbers, remember think whole numbers 1, 2, 3, between which two whole numbers of teaspoons is the amount of vanilla James needs. And if he needs 1 2/4, the number he needs has to be between the number 1 and the number 2. Because we need more than 1, the fraction tells us we need more than 1, and then but less than 2. And we also know this by the fact that we have an improper fraction right here. We know it's at least going to go over 1. Okay, and I think that's going to cover it for helping you answer all of your work that you have on page 511 and 512. And I want you to, let's look really quickly on page 512. Excuse me as I'm tearing this out of my book. Let's look really quickly on 512 because this looks a little different than something we've seen so far. At number 6. Okay, so we have a word problem, and this word problem is over 6 and 7, so we're going to be answering different sets of equations here. Okay, Leslie practices the flute for 2/6 of an hour 3 times this week. She practices piano for 2/3 of an hour 2 times this week. Which expression can be used to show how much time Leslie practices both the flute and the piano this week? Well, the first thing that I would do, guys, is I would set up my equations for these two problems. So we have a flute and a piano. So I'm going to go with my flute. What would my equation for my flute be? It would be just 3 times 2/6, excuse me. And then I have my piano, and the amount of time for my piano is going to be 2 times 2/3. And now we're going to look at all of these options. And remember, this says which expressions. So it is plural, meaning there is going to be more than one that is correct. And my suggestion to you would be to actually work out these equations to make sure that you're answering them correctly. And be very careful as to which fraction is being represented by which whole number. And referring back to the equation that you wrote out for yourself, I think will really help you. And we can go ahead and solve those as well to get our finals, because which does Leslie practice for a longer amount of time, the flute or the piano? Show your work. The answer that you get to this multiplication problem will be the answer that goes in number 7. All right, I hope that's helpful. Good luck, guys.